Year 10 Methods Pathways. We look at exercise 1.4, question number 14. Okay, so this exercise was about parallel and perpendicular lines. So just a quick recap. Parallel lines means that the lines will never touch, so the gradients are equal. So M1 equals M2. And perpendicular lines are lines which form a cross when they meet and intersect at 90 degrees. So M1 times M2 equals -1. So question 14 says, find the equation of a line that passes through 0, 5 that are parallel and perpendicular to this equation. Okay, so there's actually two parts of this question. So part A is finding a line that's parallel, and part B is finding a line that's perpendicular. Okay, so before we even find out the equation of the parallel line, we need to find what the gradient of this line is, because we want a line that's parallel to this line. Okay, so this line, we need to find what the gradient is. So to find the gradient, we need to get it in the y equals mx plus c form, so make y the subject. So if I move the 2x to the other side, we know that becomes -2x, and I move the 10 to the other side, that becomes +10. So I can easily read that the gradient is -2. So m equals -2. So we want a line parallel to this line. So parallel means has the same gradient as this, but passes through the point 0, 5. Now, what I notice about the point 0, 5 is that it's actually a y-intercept. Okay, that's perfect, because we know the equation of a line is given by y equals mx plus c. So a line that would be parallel would have the same gradient. So m is -2x, and conveniently we know the y-intercept equals 5, so we just go +5. So this is a line that will be parallel to this line, and it will pass through 0, 5. Now, for a perpendicular line, we know that the gradients must multiply to give you -1. Now, in class, I've actually shown you a shortcut to find, the gradient of a perpendicular line. If this is the gradient of the original, then the gradient of the perpendicular line would be this one flipped. So if I flip 2, I get a half, and I change the sign, so it'll be +1/2. So my new perpendicular gradient is +1/2. So, and we know that it passes through the point 0, 5, so y equals mx plus c, y equals 1/2 x plus 5. Okay, if you were to graph these two equations on the calculator, you'll find that they will be perpendicular to each other. Okay, so that's basically what the question's asking. Okay, it's asking, how do I get a gradient that's parallel, which is the same gradient, and how to get a gradient that's perpendicular, which is you flip the gradient. Okay, so you flip the gradient and you change the sign to get the gradient of the perpendicular line. And you're obviously wanting both the lines to pass through point 0, 5, so that's what happens to be a y-intercept, so that's why you go -2x plus 5 and 1/2 x plus 5. Okay, hopefully that makes sense. All right, question 18. We want to show that like these 4 points form the vertices of a square. Okay, we want to prove that it's a square. Now, the thing about a square is that these places are 90 degrees. Okay, so these are all 90 degrees. So what I'm actually proving is that the gradient of AD and AB are perpendicular. So meaning that AB, the gradient of AD and the gradient of AB multiplied together give you -1, and the gradient of AB and BC gives you when you multiply them, the result is -1, and BC and CD when you multiply the gradients together, you should get a result of -1, and also CD and DA, when you multiply the gradients together, you should get a gradient of -1. So that's basically just to prove that each of these lines, so each of these lines intersect across each other at 90 degrees. So that's basically the way you're proving that these form the vertices of a square. Okay, I'll just do a very quick one. I'm not going to do the whole question. I'm going to do a very quick one. So AB and BC. So the gradient of AB is -2 minus 3 and -2 minus 4. So that's -5 over, so -2 plus 4 is 2. Okay. M of BC is 0 minus 2 divided by 3 minus 2. So we have 2 over 5. Okay, when I multiply these together, so -5 on 2 times 2 over 5, I can see the 2's go into each other, 5's go into each other, so we're left with 1, so it's -1. So great, it shows that MAB, so the gradient of AB and the gradient of BC intersect. When they cross at 90 degrees. Okay, so you have to do that for all 4 edges. It is a bit tedious, but as long as you get the idea behind it, that should be okay. Hopefully that helps.